Hey, Vlad here from dependencies.com. Welcome to another video. Today we're going to continue learning about the reader channel. We're going to encounter a couple of issues and solve them. Well, most of them. Let's get right to it. Now this is where we left off, and before we start today, I would actually like to go and refactor our ZIO a little bit. For now, it's like 80 lines of code because I spell things out for you guys, and this is going to be a very common theme for this video, that we're going to introduce very, very powerful combinators like we did in the previous video with something like provide, right? It looks very, very simple, but it's very, very powerful. So what we're going to do now is we're going to try to shrink this a little bit, because this file that is going to become a gist is going to be uploaded at some point, and you will have to look at it. So let's shrink it down a little bit. As I already mentioned, this thing is just a fold over here, right? So we're in flat map. Okay, so this is just a fold on an either, and if it's in if we're on the left, we're simply going to fail, and if we're on the right, we're simply going to do AZB like this. Exactly the same code. Okay, now we're using this arrow or A only once, so let's go and indent it like this. Okay, so we don't need it anymore. We're simply returning this, so we don't need the variable like this, so we can throw it out like that. Okay, and now we're using this thing only once, so let's go over here, put it over here, throw this out, indent it like this, and there we go. The flat map is just one line. Okay, let's go and do the same thing over here. So this is going to be val error or B. It's going to be error or A. Now, because this is just a map, then in the left side, we're going to construct a left out of the error, and on the right side, we're going to construct a right out of AB of A, and the A comes in over here. Okay, so over here, the error comes in over here, error comes in over here, like this. Okay, the rest of the thing we can follow the same as before, right? So we're using this only once, like this, throw this out. We're not using the variable, we're using it only once. Throw this out, throw this out. Okay, now if you look more in depth over here, we have an either, we fold, right, which means we're getting rid of the either, and then we're reconstructing an either again. This is called a bimap, right? So we're doing something on the left side, we're doing something on the right side. However, what we're doing on the left side is basically exactly, it's basically identity, right? So sort of like it feels like identity. So if we were to introduce bimap, which doesn't exist on either, we would see that this would be identity, and this would be a simply AB. Right, this is how it would look like if we actually had a bimap, right? So if we had a bimap, it would look like this, and then we would realize that it's actually just a map because we're not doing anything on the left side, right? So this thing is going to compile, which is not surprising, right? A map on a ZIO simply redirects to the map on the either, right? So we just went from like what 6 lines of code to this thing. Okay, same thing over here. In fact, like catch-all is like is just a flat map on the other side. So I'm simply going to oh my God, what did you do? What did you do to me, VS Code? So I'm gonna grab this, paste this over here, and we simply need to swap the sides. Okay, so on the left we're calling the function now, which is the H, and on the right we're simply succeeding with the ZIO.succeed. Okay, so this is going to be catch-all. Like all of these lines, they can all go bye-bye. I'm going to do the same thing with map and map error. We're simply going to grab this. I'm going to paste this over here. We're simply going to grab the left side of the projection, and we're going to map it to H. Right? This is exactly the same thing, right? So now flat map delegates to fold, map delegates to map, catch-all delegates to fold, map error delegates to the map on the left side of the either. And so now we went from 80 lines to like 48 lines. By the way, guys, don't forget to hit the like button if you actually like this video. It's going to help me out to reach more people like yourself. All right, so what are we trying to do today? Well, we're essentially trying to test this application today. And as of right now, as it stands, it's kind of hard to inject dependencies into it because, for example, for console, we don't even have a trait. For business logic, we do have a trait, but it seems like the dependency graph is already assembled. Now, what I'm going to say next is going to be a little bit more confusing because we were kind of like on the road to Z layers, and we need to diverge a little bit because the thing is that once we go into assemble this full application with layers, it's going to be hard to explain what we're doing now, because right now we kind of have like this loose program that is kind of laying around over here, and I can simply massage it like the way I want. However, as soon as we have like this very rigid structure of traits and implementations and proper dependency injection, it's going to be hard to introduce this. Now, what we have seen so far was a regular dependency injection with constructors, and relatively regular dependency injection with ZIO. It's pretty much the same. It's a little bit more inverted, but look, it's pretty much the same thing as over here. What ZIO actually allows you to do is also have the dependency injection on the method level. So what we're going to do now is, in fact, for 2 videos, we're actually going to diverge a little bit from Z layers, but then we're going to come back to them, right? And we're constantly going to mix and match. And I know that it's going to be confusing, but believe me that it is necessary. So again, the problem that we're trying to solve is how do we inject something into this program. We can't inject console now, as already mentioned. We don't have a trait yet, and we will introduce it a little bit later. For now, let's just say that we wanted to introduce a fake business logic over here. Usually, a lot of people, they don't even fake the business logic, right? But this is the example that we're rolling with right now. So let's say that we wanted to inject the fake business logic. Well, in the beginning, it's very simple, right? So we can just go and we can say def make program, and we can just inject it, right? We're on the method level now, right? We're not on the constructor level now, right? Simply going to inject it, business logic, okay? And now we don't need this, right? And now it's gonna look like this, okay? And now for the actual program, all right, we're gonna have lazy val program, right? Because we need to pass in the program over there, okay? So now over here we're going to have the for comprehension, right? And surprise, surprise, what is it gonna have over here? It's gonna take the business logic out of the dependency graph.make, and now it's going to get the program out of make program, right, with business logic like this, and it's going to yield the program, okay? And now this is a dependency injection point, right? So if you wanted, we could inject a fake one. This should be live, like this, okay? Same thing, right? But now we can inject something. Let's look at the types. So this program constructs a ZIO that does not require anything, right? Because it already received business logic in the constructor, so to say. I mean, it's a method, but you know what I mean, right? So we're ending up with a ZIO that doesn't want anything. And therefore, over here, we're going to have exactly the same thing. Now, what about the reader way, right? And we already had an example where we don't use the constructor dependency injection, but we use the reader way. And we use this over here in business logic, right? So for example, over here, this is a ZIO that actually wants something, right? And how did we do it? We did the from function thing, okay? So this means that instead of having like this whole thing over here, right, we can comment it out. This can become, again, simply, maybe I should comment it out like this, okay? This is going to become lazy val program, right? And it's going to be the equal sign over here. And now over here, we're going to go and we're going to say business logic, and we're going to rip it out. Well, out of what? We need to rip it out of thin air. And as already shown over there, we did from function. And what kind of function this is going to be? Let's actually scroll up again and look at this one, right? This is going to be from function, and the function was, okay, Google comes in, business logic comes out. Well, over here, well, we can't give it anything. I mean, we want the business logic. Like, how are we gonna get the business logic? And this was like one of those weird things that that are like really hard to understand once you start using the reader mode, because it's like so inverted. Now it turns out that we can use the identity function, right? So we're creating a ZIO that is going to have the business logic both in the reader channel and in the success channel, right? So it's simply going to give it back to you. Like whatever you give it, it's going to give it back to you. Okay. So we're going to have over here a business logic. Okay. And we're simply going to give it back. Let's see if this part compiles. Okay, so this part compiles, right? So this is now a program that wants a business logic, right? So how are we going to give it? Well, this is a program that wants a business logic. Well, we have provide dependency graph dot make. We cannot use live over here because live is going to become a layer, and then at some point we're going to have a function called provide layer that will receive the live version and then inject it properly. All right, so again, this is just the identity function. It takes the business logic and it returns the business logic. Okay, so over here we can just simply use identity from predef. Right, we cannot leave the types out, right, because everything needs to be inferred. So we would need to specify it over here, and then we would need to be able to. Then we might be able to leave it out. Let's try it. Business logic, nothing, unit, and no, it's not enough. But it will be enough with once we're done. Okay, let's remove this. Like this. Okay. Now, this is sort of like a common thing in ZIO. So obviously there is a combinator that is going to do this. So let's go and add it. There's actually a couple, and they all have exactly the same name. So it needs to be in the ZIO object, and we're going to call it identity, right? So we're going to give it like R is, the business logic, right? So we're in the companion object, so we don't have an R, okay? So, and it's going to produce a ZIO of R, nothing R, right? It's just gonna, just gonna give it back. So it's gonna do ZIO.from function, and we're gonna go to predef dot identity, and because the types are so close, it is actually able to infer. There's another one in ZIO called environment that does exactly the same thing, just called differently. Environment, right? It just calls identity like this, and we can actually make it an inline def so that the compiler will inline it. And I also prefer the name read, right? Because it's the reader mode, right? So it reads something from the environment. Like this is not part of ZIO, but I want to have it. Okay, let's have like not part of the real ZIO. Okay, like this. So what this allows you to do is we can go over here, and now we can say simply, for example, environment, right? Environment, and we can simply say business logic, and it's simply going to get it out like this. Okay, and if we leave it out and we specify the types right over here, if we're going to say that this is going to be a program that produces a ZIO that wants a business logic and nothing unit, right? Then the compiler is actually going to be able to infer it. That's what I mentioned a couple of minutes ago. Now, ZIO has developed a pattern that you don't even have to do this thing, right? So the idea is that you create some boilerplate. Basically, you move the boilerplate from the call side, which is over here, to the declaration side, right? Then you have some boilerplate, but you write it once, and then everybody who's going to call it is going to benefit from it. So now we're going to start gradually introducing it, and in the beginning, it's going to actually be more code. Okay, so the first step is to indent, basically to inline this this call to flat map and map. Okay, so what we're going to do over here, right? We're going to have the cats, right? We're going to say, okay, give us the ZIO environment for the business logic. Okay, and then we're going to map it underscore to that part like this. Okay, so there's going to be cats. There's going to be dogs like this. Okay, and now in between, we're going to have console.put string line cats to string, and the same thing with the dogs. All right, over here, dogs. Okay, so now we can throw this out, right? And this has like sort of like the benefit that we don't need to do this anymore, right? So it's exactly the same thing, kind of, but we're using this thing twice. So now we're going to start making it prettier. So we're going to go over here. We're going to introduce yet another one, and we're going to call it access. Access. And as the first step is going to do exactly the same thing. It's just going to look prettier, right? I'm going to say basically access the business logic. Now, what we want to do next is basically get rid of map, right? So we want to make it look like this, right? So we're just accessing the business logic and then doing this thing. Okay. Now, basically, we could overload map, right, and call it apply, but we're going to run into issues with type inference, and also we're going to run into issues once we're going to create an overload of access, which is going to be called ZEnv. Okay, and we're gonna get there in a second. Okay, so there's a little trick. So we're gonna use a case class or like a regular class, and we don't need to use new, right? So we're gonna call it access partially applied. Okay, like this. Okay, so it's just going to be a tiny class. I'm gonna put it over here for now. Okay, so it's just gonna be a final class. It's access partially applied. Come on, not access mode. The whole point of this class is to hold this R parameter. It's actually not even going to have any parameters of its own. Okay, and now that class is going to have apply. Okay, apply, it's going to produce an A. Okay, it's going to get a function from R to A. Okay, from this R to this A. This is another benefit of having this, because we're going to have a better type inference, because we need to specify only one parameter instead of all the all the others like this one. Okay, so it's going to produce a ZIO of R nothing A. Okay, and it's simply going to get it from the environment, right? So it's going to get the R from the environment, and it's going to map it to the function, right? And because everything is so close over here, if I spell correctly, environment, like this. Now, this thing doesn't return a ZIO, it actually returns an access partially applied like this of R, like this. So now we can go to main, and we can simply save it, and it's going to work, right? So access simply returns and access partially applied. It has the apply method that received this thing, and it looks a bit prettier now. Now, we're still not done, but let's already introduce access partially M, right? So we're gonna do, because like in a second we're gonna go and rewrite this thing in such a way that these functions actually return a ZIO, this one and this one, and we're gonna need a function that was going to delegate to flat map instead of map. Okay, so let's put it down over here, right? So we're gonna call it accessM, and probably for monad, access partially, well, let's call it accessM partially applied. That's how it's called in ZIO, I believe. Okay, so, and it's going to simply call accessM partially applied. Come on, not mode, like what is happening? Partially applied. It's going to be a tiny class over here. Oh man, final class, accessM partially applied, like this. It's gonna trap the R, it's not gonna have any parents, and it's gonna have apply that is going to look pretty much like the rest of flatmap, right? R, ZIO, REA, and it's going to produce a ZIO of REA, and it's going to be environment. Oh my God, environment. This time it's going to be flat map to F. And by the way, we don't need to actually specify the type. Hold on, that's actually interesting. Should we use new over here? I did not need to do this before. And by the way, because we're so close, we don't actually need to specify the parameter over here. Let me actually put these classes out. I'm going to take this and I'm simply going to, I don't know, have them over here. And this one as well. This one. Let's have it over here. Okay, like this. So that's going to be ZIO.environment. Let's continue with the pattern because we're actually not done, right? Like even though it got a little bit better over here, we still need to specify the types, and you know it's actually very, very long. Like in the beginning, we were just saying console dot. Business logic dot, does Google have even amount of pictures of, right? So this pattern continues, and in the end, we're going to come back to exactly this code. We're going to be able to say business logic dot, and does Google have even amount of pictures of? And the way we do this is we have an object that is going to surround the entire business logic, and it's going to be called business logic, but with a small b, right? So we're just going to put an object over here, business logic, right? And then once we're done, all right, so we're going to indent this whole thing. Once we're done, we're going to have a def over here that is going to be called like this, right? And then in the full comprehension, we're going to call, you know, business logic dot this, okay? But for now, let's actually go and fix the errors. So what is wrong with metals? Why doesn't it show me the errors? There are like 7 of them. Look, it doesn't show me anything, but there are obviously errors because now this thing is inside of an object. All right, let's go and find them manually then. Okay, so we have business logic over here. So there's going to be business logic dot and business logic dot, business logic dot, business logic dot, business logic dot, business logic dot. I think it was 7. I still missed something. Something recursive. Okay, Metals woke up. Yeah, we should probably use BL over here. For business logic, BL. Same thing probably over here. Okay, we need to do this. And let's also do this BL. And let's also do this BL. And so that it doesn't happen in the future, let's also use G for Google like this. And we don't need this type over here. Like this. Okay, so this is the old way. This is the new way. All right, cool. So it's all fixed now. Let's go and actually add this helper. So it's going to look exactly the same as this thing, right? So it's going to want a topic, but it's going to produce, and it's sort of like the purpose of it, right? The purpose of it is to require the business logic, right? Require the business logic, and then the rest is going to be nothing Boolean, okay? How is it going to do this? Well, the same as we're doing it at the bottom, right? So it's going to go and do ZIO.access business logic, and I'll do this whole thing, right? So we're just going to copy it, and we're going to go and paste it like this. So we're going to indent it like this. All right, and this is not going to be cats, this is going to be topic like this. All right, and yes, it has to be business logic dot. Oh, actually, it doesn't need to be because I netted it like this, right? So it needs to be inside of this, okay? And because we're so close and the type is actually there, we can do this, and we actually don't need the entire type, right? So we just access it like this, okay? Now this allows us to just go and do business logic dot, does Google have this thing? So we can go and do this, okay? So instead of this, and well, actually, no, instead of this, right? So we can just say business logic dot like this, okay? And the same thing for all the dogs over here, right? Dogs like this, okay? So now we're back to exactly the same program as we had before, okay? So business logic is just an object. This thing is something that requires the business logic. It's gonna rip out the business logic from the environment and inject it, okay? In fact, I believe at this point, we actually don't even need the types over here, right? It's still going to be inferred, right? It's the ZIO that wants a business logic. Let's change one last thing because I want to make this code a little bit more functional. I cannot look at it anymore. Okay, so it returns a Boolean over here. We're actually going to change it to ZIO any nothing Boolean. And we're going to have a very serious conversation about this over here a couple of videos from now. Okay, so ZIO any nothing Boolean, copy. Now Google is also going to return us a ZIO. So when we're going to call this, we need to do .map underscore like this. All right. So because of this, we need to do .accessM like this. Google over here. So this is going to be ZIO of any nothing int. Let's go and grab it. It's going to be ZIO any nothing int. So we just need to do ZIO.succeed. ZIO.succeed like this. Succeed like this. There we go. And yeah, it already works, right? So this is like the only couple of changes that were actually required because now this thing calls AccessM instead of access, right? So it delegates the flat map and it's all good. All right, now we're pretty much done for this video, but in the next video, we're going to keep talking about the reader channel. Allow me to give you sort of like a sneak peek to how to the problem that we're going to encounter in the next video that we're going to try to solve. If we go back to the real ZIO right now, in the real ZIO, the console already follows this pattern that we just did for the business logic, right? So it's wrapped in an object. It has a trait and it has like, put string line. It has like these delegation methods, which means that if we go and go to the real ZIO, it's going to fail with a very interesting error message. Now we have a program that does not just require the business logic. It also requires the ZIO console. And the question is, how do we combine them? Like, how do we create such a compound type? And this is a problem that we're going to be trying to solve in the next video. I'm showing this to you to ask you the following question. This is the 5th video in the ZIO series. Well, technically the 4th in which we are writing code. And so far, every time when we were jumping between the real ZIO and our ZIO, everything compiled. How? Now, one of the reasons is that I'm a freaking maniac and I spent countless hours preparing these videos to drive you exactly to this point so that I can show you what I'm going to show you in a second. And the other answer is the ZIO environment. All right, let me actually show this to you real quick. So let's actually go and go back to this. Okay, let's actually go down over here and switch it back to this, right? To this and this and this, okay? Like that. So now we don't need to provide anything like this. There we go. It's now in business logic dot business logic, and we probably should call it BL then. BL like this. Okay, so this thing works. And it also works with the real ZIO. But in the real ZIO, the console is actually not just an object. It has, it has a trait and it has a delegation thingies, right? So if we go over here, right, we'll look at the console. It's going to be ZIO console, and put string line is going to be something that requires a console, right? How does this work? And the answer is the ZIO environment. In the ZIO environment, the the ZIO's environment is not some silly unit. It is actually a compound object that comes with a console, with a clock, with a thing that can take the environment variables from your programs, the operating system environment variables, not the reader monad environment variables, and also with a thing called blocking that is a concurrency thing, and many other things. So in the upcoming video, we're actually going to go and inject at least a console over here so that we can arrive at the same point with ZIO, right? If something doesn't compile in ZIO, it also should not compile in our ZIO as well. We're going to talk about all of this in the upcoming video. For now, as always, it's Milblad from dev.ZIO.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider support me on GitHub sponsors or Patreon, whatever you prefer, and I'll watch my videos weeks and sometimes even months before everyone else, including this series. And most importantly, take care.